Hello, pre-cal. Welcome to Unit 9, Day 5, Zeros of Polynomial Functions. Quick review of imaginary numbers. Don't be scared. Usually whenever we're going over imaginary numbers, it gives us a bit of fear and anxiety, but it's not too bad. Just a quick review. What that really represents is the square root of -1. You can't take the square root of a negative number. I represents the square root of -1. I squared is really -1. If we needed to simplify the square root of -5i, that would be I root 5. And if we were to take the square root of -16, now the square root of +16 is 4, but the square root of -16 is 4i. I just serves as an indicator that we're taking the square root of a negative number. I's always come in pairs. If -3i is a root, then what is the other root? +3i. They always come in pairs. If 5 plus 3i is a root, then what is the other root? 5 minus 3i. Example 1, simplify the following. Okay, we have example A here, 2 plus 7i minus 5 plus 6i. Y'all have been doing this for a long time, but usually instead of I, we see an X. We're going to treat this in much the same manner. So 2 plus 7i, we'd want to simplify what we could in parentheses first, but there is nothing we can simplify. So I'm just going to copy it down and remove the parentheses. That negative, we would need to distribute throughout the parentheses. So now we have minus 5 and minus 6i. And now we're simply looking for like terms that we can combine. 2 and -5, if we combine those, we get -3. 7i minus 6i would just leave us with 1i, or just positive I. That can no longer simplify. That is your final answer. Now for example B, this time we're multiplying. Let's FOIL 3 times 2. 3 times -i. 4i times 2. And then be careful with this one. 4i times -i would be -4i squared. I'm going to combine these two right here, -3i plus 8i. Now anytime we see I, we want to leave it as I. We don't want to change it to the square root of -1. But whenever we see I squared, we need to remember that's really -1. So I changed that. And if I simplify a little bit further, this is a multiplication problem. -4 times -1 is +4. And now we can combine these two integers, the 6 and the 4. 6 and 4 is 10 plus 5i. So that would be your answer there. Over here, 9 minus 5i squared. Please do not make the mistake of simply squaring everything that you see in parentheses. A binomial that is being squared means we have two of the exact same binomials. So 9 minus 5a times, I said 5a, I meant 5i. 9 minus 5i. So now we would need to FOIL again, and I will start doing that now. 9 times 9, 81. 9 times -5i. -5i times 9. -5 times -5 is +25. Both of them had an I, so I times I is I squared. -45i minus 45i, we can combine those, that'd be -90i plus 25 times I squared, but remember I squared is really negative 1. (25) times negative 1 is negative 25. And now what is 81 minus 25? That would be 56. So 56 minus 90i. That would be your final answer. Okay, write the equation of the polynomial with the given roots. 2i and negative 2i. So here's one way of doing them. These are roots. So we could say x equals 2i and x equals negative 2i. Now what I'm going to do is I'm going to set both of these equations equal to 0. So this one, subtract 2i from both sides. And over here I would need to add 2i to both sides. Okay, now going forward, I don't need the equals 0 portion anymore. I just need what I have here. I'm going to take these two sets of parentheses and I'm going to go ahead and start foiling them together. X times x. X times 2i is positive 2xi. Negative 2i times x, negative 2xi. Negative 2i times positive 2i would be negative 4i squared. Simplifying, x squared, notice these two terms cancel one another out. Minus 4i squared minus 4, but remember I squared is really negative 1. So now we have x squared, negative 4 times negative 1 is positive 4, and we now have a polynomial equation that would produce roots of plus 2i and negative 2i. That would be your answer. Example 3, find all the zeros. X cubed plus 4x. Let me write that just a little bit bigger. X cubed plus 4x. If we're going to find all the roots, what I notice is that these two terms both have an x in common. So we could factor out an x. Now both of these are factors. This one right here we could go ahead and set equal to 0. X equals 0. So we found one of our roots. X squared plus 4, if we set that equal to 0 and solve, well, it cannot be factored, but we can use the square root method. We can subtract 4 from both sides. Then take the square root of both sides. X equals plus or minus, don't forget your plus or minus symbol. Now remember, the square root of positive 4 is 2, but the square root of negative 4 is 2i. So we've now found all the roots. 2 of them are imaginary, and 1 of them is real. Example B. Graph y equals x cubed minus 5x plus 7 on your calculator. What do you notice about the zeros? I'm going to go get my calculator right now. And I'm back. Okay, I don't know. Let's see. What do we notice? Clear that out. X cubed minus 5x plus 7. Let's graph it. What do we notice about the zeros? Notice that this graph only crosses the x-axis once. Since it only crosses the x-axis once, that means we have one real zero. And since we only have one real zero, then the other two are imaginary. How did you know that, Mr. Flores? Excellent question, student. Notice that this is written in standard form. When it's written in standard form, identify the term that has the largest exponent. There. Notice that its exponent is 3. That tells you how many zeros your function is going to have. So we're going to have 3 of them. One of them's real because we only cross the x-axis once. Therefore, the other 2 must be imaginary. And remember, at the beginning of our notes, we learned imaginary numbers come in pairs. Example 4, find all the zeros. Try by factoring. Let me start by making this a little bit bigger because that's really hard to see. Boy, there's nothing quite like writing with a brand new Sharpie. It's so, well, sharp and precise. I like it. Now, looky here. We have 4 terms, 1, 2, 3, 4. A lot of times that means we can factor by grouping. Out of this group, we could factor out an x squared. And that would leave us with x plus 1. Out of this group, looks like we could factor out a positive 9. And that would leave us with x plus 1 again. Let's now group the outside terms, that being the x squared and the positive 9, and keep one set of the matching parentheses. Well, now we can set these equal to 0 and solve. So x squared plus 9 equals 0. Can't factor, but we can solve using the square root method. Square root, x equals, don't forget, plus or minus. The square root of positive 9 is 3, but the square root of negative 9 is 3i. There's 2 of our zeros. The other one's here. If you set x plus 1 equal to 0 and solve, we would get negative 1. So we've now found all the zeros by factoring. Try by synthetic division. No thanks. Don't worry about that. Okay, let's now move on to the very last problem that we have today. Example C. Find all the zeros. By the way, one of the factors is x minus 1, or f of 1 equals 0. So they're giving us a tremendous hint. If you tried to factor by grouping here, you would find out, well, you'd probably notice this is weird. This one isn't quite working the way the previous example did. That's because that one can't factor by grouping. If they give you a factor, they want you to use it. That's what they want you to do. Here's what we could do. We could set x minus 1 equal to 0. Remember, when they give you a factor, set the factor equal to 0 and solve for x. So we're going to use synthetic division, and we want to divide by 1. Or they told us here, use 1, because when x is 1, y is 0. So we can just use 1. That's what we're going to do here. Put a 1 right there. I'm looking at, looks like we have 4 terms here. The term with the highest exponent is the cube. So now we want to work in descending order. We need a square, then a variable x term, and then a constant. And they didn't skip any exponents, so that's good news for us. All right, bring down the first coefficient. Now multiply. 1 times 1 is 1. Combine negative 3, positive 1, that's negative 2. Multiply. 1 times negative 2 is negative 2. Combine. A 4 and a negative 2 is 2. Multiply. 1 times 2 is 2. And negative 2 plus 2 cancel one another out. We do not have a remainder. Now bring down your variables and decrease the exponent by 1. And this was a positive 2. So that leaves us with x squared minus 2x plus 2. Now, give me just a moment. What are we supposed to do with this problem? Find the zeros. Okay. So let's, you know what? Let's try and factor. What are the factors of 2, 1 and 2, that add to get 2? Oh, darn. This one isn't factorable. So we have to use the quadratic equation. A is 1. B is negative 2. And C is 2. Now, in previous classes, we have covered the formula for the quadratic equation, so I don't feel the need to give it to you yet again. So I have labeled A, B, and C. I'm just going to start plugging into the quadratic equation now. So it starts opposite B, plus or minus square root of B squared, which would be 4, minus 4 times A times C, all divided by 2 times A. Now let me start simplifying. 2 plus or minus square root of 4 minus 4 times 1 times 2, which would be 8, all over 2 times 1, which is 2. Okay, simplify a little bit more. 2 plus or minus square root of 4 minus 8 is negative 4, all divided by 2. Let's simplify again. 2 plus or minus the square root of negative 4 is 2i, all divided by 2. And now we can simplify. Every single one of these terms is divisible by 2. So we're going to divide them all by 2, leaving us with 1 plus or minus I. We have now found all of the roots. Here's 2 of them here. And the other one, remember, is there. So our answers are 1 and 1 plus or minus I. Have a wonderful day.